Okay guys, just making a quick video here on full excellence working, including the two difficult parts for excellence on the guitar problem that I posted on the Google class. So just going to go through the working here. The constraints have been turned into inequations here. We have 2x plus 2y plus 2.3y is less than or equal to 1500, which you plot. Same for the others. By now I'm hoping you guys are actually reasonably good at doing this plotting of the constraints. You do need to use the point test to work out which side to shade out, and also there is a profit equation, $100 profit on the Charvel and $250 on a Gibson. Notice this is not the same as the assignment that I set. This number here was changed to make the problem much more like the assessment. And that gives the profit equation there. I just want to quickly talk, for those who haven't seen it, on how to use the calculator to do all of this. So scroll back a little bit and we see that we have the equations written out here. 2x plus 2.3y is less than 1500, and so on all the way down. Notice that I've lined up the x's with the x's, y's with the y's, which is helpful for the calculator part because you really want to make a little table for yourself of these numbers: 2, 2, 2.3, 2.3, 1500, 1500. And that enables us to use the calculator to, of course the light's right there, isn't it? To solve these kind of problems. So what we're essentially doing is finding the intersection of any two of these. For example, if we want to find the intersection of line 1 and 2, constraint 1 and 2, we've got to enter in the numbers there. So calculator on. Often it's in this mode or some other mode, so you've got to push the menu button first, then seek for the equation one and what number you have to push to get into it. In this case, on this calculator, it's 8. Some of them it's actually a letter, in which case it's one of these letters, A, B, C, D, or whatever. But I push 8, and that takes me into equation mode. We're choosing simultaneous equation, which is F1, and we're choosing two unknowns, which is also F1. And we get our blank template here. Now we want to enter those first two lines. 2, 2.3, 1500, which we can just do 2, enter 2.3, 1500, and 2, 6, 3000, 2, enter 6, enter 3000, enter. Enter takes you on to the next one every time. Then after that, check it, make sure you get the right numbers in there, push solve. These numbers that come up are your x and y points of the solution for that line. So I have 283.7, 405.4. Just note that that is the intersection of those two constraints there, 283.78 and 405.4. If you've drawn them on your graph, it's where the two sloping lines cross over each other. If you want to enter another one, you push repeat. You'll often be able to just use one of the lines you already did, so you could arrow around. If I wanted to find the intersection of equation 1 and 3, I only have to enter line 3 into the second row, 1, 0, 30. So I go 1, enter, 0, enter, 30, enter. And then I'm finding push solve, which is F1, and I'm finding the other point, where does 1 and 3 cross, which in this case was not marked on the graph by the looks of it, but just looking at my graph, I'm not seeing it marked. It's the other one of the other intersection points here. Another thing I wanted to note for you, just in case you did get fractional equations, you can repeat this. you did get a fractional answer somehow in there, like 1/100th, you can enter this using this calculator. You use this button here. And I'll show you that. So I'm going to enter 1/100th. 1/100th. It shows it like this, and that is now converted for you, but it will actually be showing in there in the fraction form here. And the answer will often come up in the fraction form as well. You can also enter improper fractions doing this. If I wanted to have 1/100th, it would just be 1 and 1/100th. Duh. Let's do that again. So 1 and 1/100th. Yeah, notice how that's come out as 1.01 just here, which is correct. But if I go and look at it, it's showing it as 101/100ths, which is the improper fraction for the same thing. And you can do that, you can use that method for doing improper fractions also in calculation mode on one of these calculators. So if I go into the menu, number 1, I can enter 1/100th. And it will do the calculations like that. So that's how you read fractions and improper fractions in this mode on the calculator. So, coming back to the problem, we found all our critical points. We go through all of the combinations of those lines and we find these points here, 1, 2, 3, 4 of them. And the next part of the problem is to essentially check for the optimality of the solutions and identify which one of these is the best point given that profit equation that we had. Profit equation, notice, is right here. I've written it down in a table like this to maybe make it a little bit easier to work out how to do the bits and pieces. You've got your X and Y's are your critical points, B, C and D. I'm not going to bother with A because it's way over here. So, and then you calculate the profit. And I've highlighted the biggest one. At that point, we've gone to darken the room. We've got to write this line. To maximise profit, Callum and Bailey must order 283.8 Shavo and 405.4 Gibson guitars to make a profit of $129,600. Actually, I've written out the wrong profit there. That would be the one from rounding the numbers, so I put in a point C rounded. At this point, we've made no effort to check whether or not that point is, in fact, feasible, which is the next part of the problem, working out the feasible solutions. So, around that point, given that it's not the answer there, the most optimal one here is two numbers that are not integers. We need to find the nearest integer around them. So, we try all four combinations. So I've got them here, 2 and 4, 406, 284, 405, 283, 406, 283, 405. Those four combinations there, all the ways that you could, all the points around the critical point that we found here. And what we do is we go through and check them for, firstly, optimality and feasibility. You can do that in either order, but if it's infeasible, there's no need to check the optimality, so I check the feasibility first. On the first one, I put it into the first constraint here, which is constraint 1, and I get this number back, 1501, which is bigger, not less than or equal to 1500, and so this is not feasible. I don't have to work out the second constraint or the optimality. Okay, this here is the optimality, this function P. The second point I look at, I work out both these constraints are actually okay. I plug it into 2x plus 2.3y and I get 1499.5 and 2998, and both of those are less than the constraint values. So this is feasible, so I work out a profit for it. The next one I go on, I look at constraint 1 and I go, it's feasible there, but then I put it into constraint 2, 2x plus 6y on these two numbers gives me 3002, which means that which is greater than 3000. So this one's not feasible and I don't have to calculate the optimality. Then I go to the last one, I work out constraint 1, constraint 2, both of them are less than the constraint values that they're required to be, and so I work out the optimality. Now I've got two feasible solutions, this one and this one. I just have to pick the one which is the most optimal. In this case, it's this one here that it's got the box around it, point C2. And then you answer the question, to maximise the profit, they must order this. And that's an excellence level answer. Even though it gives the same answer as the other one, that was only found by rounding, which is not guaranteed to give you the correct answer anyway. I can't guarantee that it would do that in the actual test either, the assessment. Okay, the last part of the excellence is changing the ordering of the guitars because of uncertainty in recent global affairs, suggesting a reasonable profit scheme that enables different combinations. What we need to do there is find a line that is parallel to one or other of these two constraints. I'll show you on Desmos quickly what these look like. This is the current constraint line, the current profit line, right on the optimal solution there. It can move around if I change the profit here, up and down, and essentially our search found us that point there. What you need to do is find a new equation. So let's change that one. It can either be parallel to this line here or that line there. Your choice really, but one of them is usually easier than the other to match up, because if we have a look back at the actual equations themselves, one of them is easier to turn into the right numbers. X is 1/3 of Y here, so 2 is 1/3 of 6, so we just need it to be linearly proportional to that. So we change our profit equation, and the suggestion in this one here is to do it to 150 and 450. I would have chosen 100 and 300 actually, to be honest. I didn't do this working, but because it's even closer to the original values. But that's fine. I mean, this is basically saying they'd put the price of the bikes up quite a lot, and they would get a new profit line that gives them this ability to have optimal profit, but with different stocking levels of the two types of bikes. You've got a point. You've already got a point on the line. So what they chose is the blue line here. This is the constraint that they've made it parallel to, this blue line here. And I think I'll just show that one. So this little red line here is my blue line. And I can slide that up and down. And you'll see when I slide it onto the line, it's completely parallel to the blue line right there. So every point along that line is actually an optimal solution now, including the endpoints. So you already have a sample point for this in the space, the endpoints. Both of them, this one here and that one, are now optimal. And so you can look at, simply put the both of those into either one of them into the profit equation. The B point is actually easier because it's got integer values. It gives you 225. If you put the other one in, it actually gives you the same value anyway. You don't need to check the others. That's not necessary. So the last part is to then go, okay, so my profit equation is this P equals 150x plus 450y. And actually P is 225,000. And anywhere along that line, Callum and Bailey can order integer values of the guitars that lie on that line to make a profit of $225,000. You could go one step further if you had the time. That statement is enough at this point for excellence part 2, which is complete excellence in this task. But if you wanted to go one step further, you could actually find the conditions of the points themselves. So you'd actually solve for y. And I'm just going to do that, but first I'm going to get the lights back on. That's better. Turned off on me in the middle of doing all of that. So we've made a profit equation of 150x plus 450y equals 225,000. And so we solve that for y, which is and I'll just check some of those numbers, 225 divided by 450, 500, and 150 over 450. Is 1/3. So we get that. And what we can see there, this is y, is that every time x is divisible by 3, multiple of 3, then this number here will be an integer. This one's already an integer. So you can find some values for x that fit the equation. Oh, the last part I should also say, you must say that the x value lies between the 2 points. So point B and point C. The x value must be between 30 and 283.8. When you're stating this, you're saying it's anywhere on the line between those 2 points. If you do it this way, you would say that x is between 30 and 283. And divisible by 3. So that will give you a series of numbers. You can put any number in for x, 33, 36, 39, and so on. Find a y value from here, and you've got all your points all the way up to x is equal to 281, I think, or 2 is the highest one that actually divides by 3. Anyway, that's Excellent's answer.